Ladies and gentlemen, thanks for coming back to the podcast. My special guest today is astronaut Steve Bowen, who's currently out of the Johnson Space Center. Steve, great to have you on.
Oh, it's nice to be on.
Very good. Uh, as we were talking a little bit before the interview, I was recently interviewing April Jordan. We were talking about what NASA's looking for to become an astronaut, and I thought it would be really great to have the astronaut perspective as well. So I wanted to have you on and talk about some of your experiences. So I think we'll start there, the genesis of your, I guess, idea to become an astronaut. Was it one of those things that you had your interest peak when you were a kid, or did you sort of develop that as you got older? Talk about your story there.
Well, I am old enough that I actually watched, Neil Armstrong step onto the surface of the moon in July 1969. I was pretty young then, and the concept of becoming an astronaut seemed completely far-fetched. But I think what that did, though, was sort of stoke my interest in engineering and science, and probably led me down that path at least to start with. And so I followed the space program. Uh, you know, I won't say intently, but it was in the news, and I followed the news all the way through school. So when I studied math and science, I just guess had a natural proclivity toward it. And so I went to the U.S. Naval Academy and I joined the submarine force after graduation, spent 14 years in the submarine force. And I saw the opportunity to apply in 1998. I was on shore duty. Uh, and so the Navy put out a message and I looked at it and I looked at the requirements and I looked at what they were doing. We were just getting ready to really start the International Space Station. I had followed NASA along the way, and I knew how close it was to not having a space station at one point. But they were just starting to build that, and I thought about it. I said, you know, that environment is very similar to where my background is. It's a enclosed environment and inhospitable place, and it'd be a really interesting thing to do. It's something maybe in the way back of my mind, it existed as a concept, but I never thought that I'd become an astronaut. So all I did was I literally followed the instructions on how to apply. I followed the Navy instructions, and I worked my way through the process, and the process was a bit different back then because I did have to apply through the Navy. Now it's basically USA Jobs does all that work for us as well. But I also never expected to actually get selected. So being selected was quite amazing. And what I realized was that along the way, I had never done anything to preclude becoming an astronaut. I had basically done my job, done my all my work as best I could. I really enjoyed studying, so I'd get my master's degree, actually my engineer's degree from MIT, and it just became something.
Hmm.
I never totally planned on it in my career. I probably would have been perfectly happy being in the submarine force uh, at the time, but it's just the thing that sort of a childhood dream come true that you never thought you could get to.
That's really interesting. Now, you talked about working in two industries that are confined environment and dangerous when you go outside, Uh, but surely there are still differences. What are some of those differences between being in a submarine and being up in the ISS?
What really surprised me, and I spoke to submarine community last November, how it was more how similar it was. The operating environment on the International Space Station is very similar to the submarine deployment, where you follow into a routine on a day-to-day basis. Now, the actual business you're doing, and the research and science we do on the International Space Station versus operating a submarine is completely different. So the job itself is completely different. The environment is very much the same. The operations are very much the same in the sense of how they're paced. The biggest difference, obviously, is that the crew is much smaller. We brought up a crew. We had a crew of four. My Dragon was a Soyuz crew there, so it's a total of seven on board station. You work pretty much independently for the most part on board space station. The ground is continuously watching. They help out along the way. You have some events like EVAs and vehicle dockings and a lot of science that involves more than one person. So you do get to work together sometimes, but it's a completely different operational uh, place than it is the summer, and it's quite amazing actually.
Hmm. Okay. Now, I know doing a little bit of research, you've been on four missions before. So you've been on three on the shuttle and one through SpaceX. Talk about those differences because I grew up, I'm a sort of a born in the mid 70s and the space shuttle came around a few years later and that was so intriguing. It's like, what's that? Like this big thing going, looks like a big airplane going into the sky where SpaceX is the typical rocket you'd see back in the 60s and the 70s. Talk about some of those experiences you had if you could compare the two flights going up in particular.
Yeah, the purpose of both the vehicles are where they were built for different reasons. In essence, Space Shuttle was built to build a space station. We just didn't have one for the first 15 years or so of space shuttle operations. But it was a pickup truck. We carried a lot of hardware to space. We carried whole modules to space. And so it enabled the construction of the International Space Station, did a lot of science through the years, did a lot of amazing research. It launched and recovered satellites. I mean, it was just a workhorse for that sort of work. Now, the Dragon vehicle, along with Boeing CST-100, they were designed from the beginning to safely take people to low Earth orbit. And SpaceX has already started to do some civilian non-NASA missions as well, and that was really the intent. So its concept is to provide a vehicle to get you just to low Earth, to get people just to low Earth orbit and back down safely. It's highly automated, which it has some advantages, has some disadvantages. We're still working through that. I think we're going to learn a lot about where the human-machine interface can really be improved. The So for instance, like the Dragon vehicle, from launch until we docked, uh, there was not a lot I could do for that vehicle, which it led to some waiting along the way, I shall say. But it was highly automated. It was a pretty amazing vehicle to ride. Space shuttle, we worked that vehicle, we flew that vehicle a lot more closely. And as I said, there's things we're going to learn on both of those. So that's the biggest difference. I mean, their missions were designed differently. Space shuttle, we'd go out and look at that as we were getting ready to launch, and you'd just be amazed at the size and the power. And it was it was a totally different ride than the Dragon. Uh, Dragon was just really cool. Now the actual getting from Earth to orbit. Um, you're still starting at zero. You're still ending at 17,500 miles an hour 8 minutes later. How you get there was a little bit different. For instance, on the space shuttle, we start the solid rocket boosters. Well, we start the main engines, and then 6 seconds later we kick on the solid rocket boosters. But those main engines would run the entire time. So on Dragon, first stage burns out after a couple minutes, and you basically go to zero. So you're going through zero G, which was not something that happened on the space shuttle. So while my crewmates, this was their first flight to space, that's what they expected. That seemed normal. All in my brain, I kept thinking, well, that second stage better light. So in that few seconds there, I was like, this is not right. We should always be moving towards space. Of course, the second stage kicked on, and it's a great ride. It really is amazing. The G's are a little bit higher in the Dragon vehicle than we had on shuttle,
Oh,
but they don't last as long. They kind of peak and come back down, whereas shuttle, we kind of held them at 3 Gs for a longer period of time. And you still get to space and you're still floating in your straps at the end of it. So it's quite a ride.
okay. I know watching a lot of the videos of the launches, once you get out of the Earth's atmosphere, the view from I guess back here on Earth, when you're from the video perspective, it looks like you're barely even moving, even though you're like you say, you're multiple thousands of miles an hour. Do you really get the sense that you're moving that fast? I guess you don't really feel it, so to speak.
You don't feel it, and that's an amazing thing because your brain has to comprehend what you're seeing. Right, you're looking at the entire Earth rotating below you. You're circling the Earth every 90 minutes. You're seeing whole continents kind of moving. As you're looking down. You look here, you jump in the air for 2 seconds or something, the Earth doesn't move below you. So it's just an absolutely incredible thing. And your brain really has to take the time to register what's going on there.
Hmm. I know down not too far from NASA, a favorite haunt of some friends of mine is that Chelsea Wine Bar, and they upstairs, if you've ever been there, they have usually will have a big display, and I guess they're tapping into the live feed of the ISS, and you're on board and you just watching it go over. And like you say, if you look through the cloud break, there's Africa. Oh, not too far along. There's Ireland, or whatever. I know it goes a different path than that, but the point you're making is you're moving really quickly. That's got to
Yeah.
be an experience. I mean, obviously, it's an experience most people have never had and will never have. I'm sure you're asked this a lot, but if you could summarize sort of how you perceive the grandiosity of it all, what kind of feelings do you get when you see those kinds of sights down below and realize how fortunate you are to be in that position to observe Earth in a way we'll never experience?
Well, and that's actually the good word, fortunate. Uh, we do work hard and we are pretty busy, but once in a while you get that opportunity to kind of look back down and reflect. Uh, and this is actually really relatively pertinent to the events last week, the eclipse, which was I, actually it's a breathtaking thing to say. So if you haven't seen full totality on an eclipse, it's one of those experiences that is just it really rivals, if not exceeds, a lot of what we see from space station. And that's not kidding. It's absolutely incredible to see totality. But on the space station, you're there a lot longer. And I remember I was doing a spacewalk on my second flight, and the ground said stand by. And I knew when the ground said stand by, I said I'll be sitting here for a while, waiting for them to make a decision. And so I kind of was on top of the space station, just had started to install an antenna, and I literally sat there, got myself secure, and I was looking over the Russian module as we went around the world. And I had about 30 minutes or so. And all I could think of was, what kind of civilization is this, where we have all these countries working together to create this place in space where we're doing research that's really helping us understand, the Earth, mankind, materials. It's an incredible place. I grew up carrying buckets of cement for my dad. This is not some thing that was me. It's just I'm so privileged to be a part of it, and I think that's really the perspective. And you can get that here. You don't have to go to space if you just stop once in a while, look around, and look at the wonder of Earth. I mean, like I said, totality, the eclipse is a huge example of the universe as a whole, and just seeing how amazing it can be. But you can just walk outside and look at civilization. We got 8 billion people here that are for the most part getting along really well, and so it's an incredible, amazing place, and hopefully we continue to improve.
So speaking of an amazing place and people getting along relatively well, that kind of, I guess, sort of the ISS is a microcosm of that environment because as the logo behind you indicates, for people who don't know, I mean, you've got people representing different space agencies, different nations and cultures, and you're all up there in something that's maybe a little bit bigger than a football field for, multiple months at a time, and you've got to get along and you've got to bridge gaps in culture and everything like that. So kind of going into, I guess, the interest in anyone becoming an astronaut, let's talk about those characteristics a person needs to have when they're working with such diverse cultures, especially in such a confined space.
I think you really hit the nail on the head with the way you phrase that, because I think I've been around for 24 years here at NASA, and I have seen, I think, 5 additional classes come through since mine, or anyway, however the numbers work out. But every time I think we've got a little bit better at selecting people who, there's a lot of people that have the technical capability, uh, the mental capacity to do this job. You kind of have to be a generalist. You need to have hands-on skills. You need to be physically fit. You need to be able to understand the science, the engineering, how all this comes together. And there's a lot of people, especially the self-selecting people who apply. We get thousands of applications every time we open up, and it's humbling to go through those resumes, as I have several times, and scratch your head and say, why in the world did they pick me? This guy is absolutely amazing. This person is like, why am I here? And it just happens every time. So that's not necessarily what we're looking for. So when you get through the first process, the initial screening, the first, and they whittle it down, they know that anybody they select technically and will be fine. That's not the question anymore. So the rest of the process, you have to pass your medical screening. And medical is a pretty good uh, discriminator because it's I think that's a good place to kind of sort things out because we do want people to be healthy, especially looking forward. We're looking at missions ultimately to Mars that will take years. So we need to make sure you get a very healthy cohort in the astronaut office. But then the next question is, can I spend that much time with this person in an enclosed environment? And how you figure that out? Because people, you can fake almost anything for 2 weeks, 3 weeks, 4 weeks. And the shuttle missions, that's all they were looking for, is that technical capability, because we were only there for a few weeks at a time. The space station environment is not like that. You really are working together for 6 months across several nations at any given time. And you really need to have that expeditionary behavior and that understanding to really get the most out of it.
Mhm. I can imagine. Let's say there's different dietary interests between different astronauts, and maybe some smell or if something bothers you. It's like you got to tolerate that. They may not like your fajitas from Texas, but you may not like whatever spice or whatever is in the food that they eat. So that's little things like that. I would imagine could if you're not careful,
Well,
could
it's
cause
funny
problems.
that you say that, but one of the first things I noticed when I got to the space station on my first flight was how much the odor reminded me of a submarine, and that's not a nice thing to say.
Right.
You quickly get used to the odor and the sound, and kind of becomes just background. Uh, but no, that's part of the things you have to enjoy is the variety of the cultures you get to spend time with. Not just on orbit, but I mean, NASA as a whole, we work with countries around the world continuously. And that's one of the great pleasures I've had over the past 20 years is that ability to meet and travel with people from all over the world and, do hard engineering and hard science to learn.
Mhm. Steve, talk about those relationships and connections that you make from these, not just the missions that you go on, but work, like you say, working with. I know there's other responsibilities that go along with being an astronaut, other than just the months that you're on the space station. The relationships that you've made with those people around the world, because that's a unique experience many people would never have.
Well, and it's actually, if you work for NASA, there's a high probability that in your job at some point you're going to interact with one of the international agencies, whether it be JAXA or ESA, the Canadian Space Agency. There are a number of space agencies popping up. The UAE, I got the opportunity to fly with a UAE astronaut, an Emirati, and having the opportunity to work with these different countries, understand how they make some of their decisions, how the processes work within those organizations. That's we got a little bit of that. The astronaut office doesn't uh, have a lot of. We don't have a budget in the sense that we don't. We're not buying stuff. We're the operators, and that's where our input lies. But the engineering and the science and the actual establishment of how things get done, uh, those are the things that the rest of the agency works on, and it's just an amazing place to work for that reason. Well, among other reasons.
When you're not getting ready to prep for a mission, what's sort of a day in the life of an astronaut whenever if you're not, I guess, scheduled to go up on the next upcoming mission?
Well, you're continuously so. My one of my original mentors when I showed up was Chris Hadfield, and he said, more than 90% of your job is not flying in space. You're really supporting those who are in space, whether it be sitting Capcom. I'm working the next spacewalk in June. Uh, you're supporting them in meetings, or you're supporting future missions as well. So through the years, I have worked on space station uh, systems and assembly, not directly related to my missions, even though I ended up doing 3 missions doing that. A lot of spacewalks, EVAs, which is the again space station stuff and exploration. The exploration vehicles, I worked Orion, and you have the opportunity to work all these programs. And it's the meetings, it's you go to the meetings, you hope to represent the astronaut's voice in those meetings, but you're a part of that team to get these things done. And really, it's something I try to harp on a little bit when I talk to audiences, is that there is no better feeling, and it's true. It was true in the submarine force. there is no better feeling in the world than doing something incredibly difficult, and in NASA's case, seemingly impossible, flying in space uh, together as a team. Because when you get it done, you get to celebrate with everybody else, and there's no way any individual could do all of this by themselves. So it is a the most amazing team coming together, and there's no better feeling than getting things done. And that's what we are when we're not flying in space. We are, uh, we are part of that ground team supporting everything else that goes on.
Okay, so does that mean that you're a flight controller,
Well,
or
in
is there
essence, as
another
a
position?
Capcom, I'm the communicator, right? So I will be
Okay,
sitting in mission control next to all the flight controllers. Flight controllers know a lot more about their systems than I ever will.
okay.
Uh, the astronaut aspect of it, the difference there is on top of our normal jobs, we actually have to continue to train, and so I will be in the NBL for EVA runs. I will be flying the T-38 to get some of those experiences to get that training as well. There's a lot of things that we do on top of our day-to-day jobs, which really keeps the schedule very dynamic, and it's really important to maintain that operational edge. Is really what we're part of our mission as well.
So Steve, I know it takes a lot to prep for upcoming missions, but how much lead time are you given? How far ahead do you know you're going to be going back up again?
Well, that's an interesting question because it varies. So for space station missions, traditionally it's been about 2 years
Oh,
that you start your training. For space shuttle missions, it was just over a year nominally. That was what their goals were. As mission slid. So my first space shuttle mission that I actually flew, that I started training for, we trained for 14 months from the time we were assigned to the time we flew. The next mission, which STS-132, everybody in that crew had flown before, and they expected our launch date to slip. It didn't, so we only had 9 months, but that was plenty for that crew. Uh, my third mission, I got back to Earth, and uh, I was supporting the STS-133 crew as a family escort, and they had a problem in October, November of uh, 2010, and they went back to Houston in January of 2011. One of the crew members was injured, and I was chosen to fill in his spot, mostly because I had uh, the spacewalking experience that they needed that talent for, and so I only had 6 weeks to prep for that. Fortunately, like I tell children, when you take a task, don't brain dump all that information. You might have to use it again. Fortunately, I had not done that, so my space shuttle uh, training was still valid, which was good. And then for my next mission, this Crew 6 mission, we were assigned a little bit early because we were originally Crew 5, and then we swapped crews to bring in another crew ahead of us. So just over about 2.5 years for that, but about 2 years is the nominal target. And there's a lot of training that goes into that. They don't just in some ways your workload goes down because you're getting rid of your other jobs, but at the same time, your workload goes up uh, exponentially at different points along the calendar dates. So you want to make the most of it.
okay. So speaking of upcoming landmarks, I know we've got the Artemis system now, and we've already had one, and I know there's two coming up. It's been pushed back a little bit, but eventually it will be here. What are you looking
Mm-hmm.
forward to, whether it's something you may hope to be a member of a mission of, or even if you're not, just sort of watching humanity go in a different direction? Looking 10 years out, Steve, what are you looking forward most to?
I mean, it's just being a part of what's going on here at NASA. A friend of mine, Mike Barrett, who's on orbit right now, a few years ago said that he's been here longer than I have. So he's been here 30 years or so. And he said that this is the most exciting time he's ever experienced at NASA. We have so much going on, and it's so exciting just to be a part of it. I am looking forward to, first of all, leaving low Earth orbit, which Artemis 2 is going to do for the first time in over 50 years, which is a remarkable accomplishment. And then getting back to actually landing on the moon, boots on the moon with a permanent presence. And what we will learn by doing that, we people tend to talk about the science, but just the engineering will impact our lives here in positive ways. And that's really exciting for me to watch. And so, yeah, looking 10 years down the road, uh, we'll see what opportunities arise. I don't assign myself to missions, so if I'm still in the office and I'm still healthy, uh, who knows what will happen. But it's just amazing to be here.
Yeah, absolutely. So coming back down from the ISS, I know I was at the debriefing for Cruise 7 a couple weeks ago, and one of the astronauts was talking. Someone had asked him, how did you have a heart, or what did you struggle with adjusting the most? Because I know there's adjustments coming back, and he was talking about not being able to look down very much. You get real dizzy and everything. What were some of the hardest things that you've had to overcome coming back down to Earth?
Well, it's just mostly the physical readaptation to gravity, and
Mm,
that's part of what you were talking about there. The vestibular stuff, I think that came back relatively quickly. I think my body remembered my first few flights, so getting my gyros sped up and my balance back. I was walking pretty quickly, had getting better balance. Within a few days, I was reasonable. And within a few weeks, that part was fine. But getting back the physical strength and recovering from that microgravity environment, it really does take about 6 weeks. And so that's a big part of it. The thing that surprised me the most was the operational uh, impact. Your day to day, how you function, how you think about your day. Uh, on space station, I mean, you were busy from 7:30 in the morning to 7:30 at night, basically running that whole time and not having to do that. So it took me probably about 3 or 4 months to allow my brain to slow down. That it didn't have to be doing something every couple of minutes, just to keep pace. Allow myself a little bit more time to think and allow things to get done. That was a big change.
okay. In the couple of minutes that we've got left here, I'm going to ask you two quick questions. One, we talk a lot about what's it like in space, what's it like looking down from space, as we discussed earlier. But here's a little bit different question for you. When you're back down here, you're fully acclimated. What's it like when you glance up and you say, "Okay, it's up, ice is up there somewhere." What's the perspective that you now have after 4 missions, looking back up as opposed to looking down?
I used to look up. I remember as a kid going out with my dad and seeing a Skylab fly overhead. Seeing that bright star. The space station is so much brighter, so much bigger. If you ever get a chance to go outside and look
Hmm.
as it passes overhead, the amount of satellites you can see is just incredible. And the biggest change is when I look up and I see the space station flying overhead, and I think about the crew members on board, and I get a bit of a smile because I know how much they're enjoying their experience and how much uh, it really is such a unique place to have been. And I think that's what I get is that little bit of like, that is so cool, and I had the opportunity to be there. But there's 7 people living up there all the time. That's amazing.
Hmm. For someone who may be watching this or reading the story, they're thinking, okay, I think I've got some of the experiences Steve's talking about. I think I have this interest in space. I'm getting ready to hit submit on that application. If you can, Steve, encapsulate. Obviously, everyone's going to have a different experience. We can't summarize what everyone would take from this, but if you could summarize sort of the potential, if you will, in a more generalized way, potential of what that person might experience and the rewards, the satisfaction they may get from at least trying to become a member of the astronaut corps.
Well, I encourage everybody to apply. The worst we can say is no, and then apply again, right? I mean, there's no harm in applying. Uh, some of the astronauts who have done multiple missions applied many times. 3, 4, 5 times potentially before they were ever selected, and I think that gets lost on people. I think the other thing I see is sometimes people assume that the people reading their resume know what they're talking about. So the better you can explain what you do and why what you do is significant to becoming an astronaut, that's also a great thing for an application. But just apply. There's, like I said, if I had never been selected to be an astronaut, I would have enjoyed my career and really been, probably doing something else as well, maybe not as exciting, but still would be of interest to me. But there's no harm in applying. Just apply.
Very good. Well, Steve, I appreciate you coming on and sharing those valuable experiences, unique experiences so few people will ever have. All the best success and safety in the future.
Well, thank you very much. I really enjoyed it this morning.